Hello everyone, welcome to another session of Code with a Friend. So today we will continue our journey of learning Rust. In our last session, we sort of tried to learn till the match control flow operator. Even for me, and I think for this session itself, I'll sort of try to revisit quickly what we did, especially in the last chapter. So the way that's if it's divided is like per chapter we have like one Rust file and then all the source files are built into one cargo project. So it's in that way it's sort of easier to segregate. I know like the probably this naming is not right. We have to go to the main file to actually figure out which uh, functionality or chapters that we are testing here. So I think we have two test functions here, one for enums and another one for enum. Okay, let's see. So yeah, so we learned to define an enum. Um, an enum can have like a tuple of primitive types here, or it can have like a an enum on I forgot like what this data type is called. Like it is called string, of course, but I don't think it's called primitive types. Rust data types. Scalar types. So the integer ones are scalar types. Then the floating point. Hmm. Strings. So there are like string literals, and then if we want to have a match case, something like this, right? String to a numeric type, mutable string. Yeah, what is a string? Rust has only one string type in the core language, which is the string slice str that is usually seen in the borrowed form, ampersand str. We talked about string slices. The string type, which is provided by a standard library. Yeah, that's actually provided by the Rust standard library rather than coded into the core language, is a growable, mutable, owned UTF-8 encoded string type. Yeah, that's I think I wanted just to call out the difference. Like this is not actually the string slice that we can use. I wonder if we could use that here. Maybe we can try that in the later examples, but anyway, let's not deviate too much. Yeah, so I think similarly we can create, actually this should be 6. We can print 6 here. The core concept that I think was different from other languages is this concept of ownership, which is like ownership within a scope, and then when it goes out of scope, we either have to do a borrow or do a complete move of the ownership. So we'll revisit something. After some time, all of these things. But for today, we will actually continue with our remaining sections of chapter 6, which are the match control flow operator. So let me define a quick test here. Okay, we define this. Rust has an extremely powerful control flow operator that's called match. that allows us to compare a value against a series of patterns and then execute code based on which pattern matches. Patterns can be made up of literal values, variable names, wildcards, and many other things. Chapter 18 will cover all the different kinds of patterns and what they do. The power of match comes from the expressiveness of the patterns, and the compiler checks that make sure all possible cases are handled. Think of a match expression kind of like a coin sorting machine. Um, Coin slides down a track with variously sized holes in it. Each coin falls through the first hole it encounters that it fits into. Yeah, I think that it's sort of like a switch case if we want to take a programming analogy. I think the camera is bent. Hopefully it's fine. So if we have an enum, and I believe we already encountered the match cases in our guessing game code. Penny, nickel, dime, quarter. So here we have value in cents, coin, to match coin. So here we have coin penny goes to 1, coin nickel goes to 5, coin dime goes to 10, and coin quarter goes to 25. An enum and a match expression that has the variance of the enum as its patterns. Let's break down the match in the value in cents function. First, we list the match keyword followed by an expression, which in this case is the value coin. This seems very similar to an expression used in if, but there's a big difference. With if, the expression needs to return a Boolean value. Here it can be any type. The type of coin in this example is the coin enum. So next are the match arms. So if we match with something, we will return a value corresponding to that. Let's see how it pans out. I'm sorry, curly braces typically aren't used if the match arm code is short. Okay, so we can also define like full-fledged expressions here if it's not just a single value. Patterns that bind to values. Another useful feature of match arms is they can bind to parts of the values that match the pattern. I guess like we can probably print these values. Okay, and here we have value in cents. We can say coin, penny. Okay. If we run this, cargo run, does it run? There is a bunch of warning. It asks me which is the command that I want to give here. I give 6 underscore match. We got 1 here. And if we had something like this, 6 underscore match 25. So that's, I think, essentially what happens. Patterns that bind to values. Another useful feature of match arms is they can bind to parts of the values that match the pattern. This is how we can extract values of an enum variant. Let's change one of our enum variants to hold the data inside it. From this through 2008, the United States minted quarters with different designs for each of the 50 states on one side. No other coins got state designs, so only quarters have this extra value. We can add this information to our enum by changing the quarter variant to include a state value stored inside it, which we have done in listing 6.4. So something is like enum US state, enum coin, a coin enum where quarter variant also holds US state value. Let's imagine that a friend of ours is trying to collect all 50 state quarters while we sort. Okay, so it can have like a quarter with a US state. We sort our loose change by coin type. We'll also call out the name of the state associated with each quarter. So if it's one of our friend doesn't have, they can add it to their collection. In the match expression for this code, we add a variable called state to this pattern that matches value of the variant coin quarter. So let's try this. If we have, say, enum US state, Alabama, Alaska, and inside quarter we have US state. You can also put a trailing comma here, value in cents, and here we can provide, let's say, state state quarter from colon this, and then we have state here, then we return 25. Okay, so we add an additional layer. Let's see if it runs. Doesn't, because it's not able to understand that. We have to make it printable so that we can print this. Value in cents. Okay. Use parentheses to construct this tuple variant. Line 57. I don't understand what's exactly happening here. I'm literally copy pasting, but coin quarter, expected enum coin found constructor. Okay, got it. Okay, so we have to provide something like this. US state, is it the issue? Yep. Okay, got it. So we can provide whatever the state that we can use one enum state to initialize another enum, and when we compare the value with each of the match arms, none of them match until we reach coin quarter state. At that point, the binding for state will be the value US state Alaska. We can then use that binding in the println expression, thus getting the inner state value out of the coin enum variant for quarter. Matching with option T. This is, I think, the optional type. We wanted to get the inner T value of the sum case when using option T. We can also handle option T using match, as we did the coin enum. So for example, if we have +1 x option I32, which returns an option I32, you can say if it's none, then return none, then sum, return sum. So, okay, I guess like we can have maybe a different function to replicate this one. Function +1 option I32 option I32 match x none none sum I +1. Got it. Can we print it? Let's see. So this is option oh yeah, of course. I think this is why I love the compiler. And yeah, I think I just wanted to do a shout out to, let's see, to Ochre Lord, if you're watching this video. So I think thanks for this detailed explanation. I was struggling to find out one of the things to figure out why we were not able to print by passing an array to another function. So Okalod came in and explained. I eventually were able to figure out within the video, but I was not able to understand why it worked, and he explained it quite well. And his comment is there in the previous video. Thanks for doing that. So let's see. So option 32 cannot be formatted with the default format. The trait is not implemented for option I32. What can I do about it? So we can't really print, right? I think we have to get the value out of it. You try to use a type which doesn't implement some trait in a place which expected the trait. Uh, in order to fix this error, verify that yep. So how can we print this thing then? Matching some t, matching none. So I guess like I think that was already there in our one of previous examples, isn't it? Didn't we already touch it? Doesn't seem like. So the idea is like we should be able to get something out of this, or should we just try this? I don't think it will work. It does. Okay. 6 underscore match. Not match, maybe. 6 underscore option, 6 underscore option. Oh, so we got some 5. Okay, so basically we can provide this indicator here for the println function to print any option. The underscore placeholder, yeah, I think it's for like a wildcard entry, which we can use in situations where we don't want to list all possible values. For example, U8 can have valid values from 0 to 255. We only care about these 4, and we don't want to have to list out this all the way up to 255. So we can use an underscore pattern. So underscore pattern will match any value by putting it after other arms. This will match all possible cases. So what will happen if we have an underscore here? Will the compiler say like it's not necessary kind of thing? Oh, okay. So it doesn't. What if I say none? Does it run then? It does. Um, let's say. So either the option can be none or sum of something, like option of I32. So it has to be like sum of something. So if, let's say, if we for this particular case we always return sum of 0, you can do that, right? So then what will happen in these cases? So we'll print 5 and then we'll also print 6. Or probably we'll also print none, just to see what's happening here. 6 underscore option. So we have sum 0, sum 0, sum 0. So basically in none case, this is being handled here. And if we have it here, 6 underscore option, sum 5, sum 0, none. So okay, yeah. So I think in this case, what's happening is even though I'm sending a valid one, the wildcard character is catching it. So if I put it like this, now I think it's coming fine. Cool, this is interesting. Now we go into concise control flow with if-let. The if-let syntax lets you combine if and let into a less verbose way to handle values that match one pattern and ignore the rest. Consider the program enlisting 66 that matches on an option U8 value, but only wants to execute code if the value is there. So we have some U8. Then we want to match that value there with sum 3, println 3, a match that only cares about executing code when the value is sum 3. We want to do something with the sum 3 match, but do nothing with any other sum U8 value or the other none value. To satisfy the match expression, we have to add underscore after processing just one variant, which is a lot of boilerplate code to add. If let takes a pattern and an expression separated by an equals, it works. If let, okay, if let. The same way as a match. Okay, so we can do something like some U8 value, some U8, then some U8 can match on some 3, then we can do println 3. Using if let means you have less to type, less indentation, and less boilerplate code. We have lost the exhaustive checking that match enforces. Choosing between match and if let depends on what you're doing in your particular situation and if gaining Conciseness is an appropriate trade-off for losing exhaustive checking. Makes sense. We can include an else with an iflet. That block of code with goes same as like the underscore case in match expression. The coin enum definition in listing 6.4. Okay, so we can change this definition here. We can directly say match coin this, so we can convert it to an iflet option. We try another function for that. State quarter. If you have a situation in which your program has logic that is too verbose to express using a match, remembering if let is in your Rust toolbox. Yeah, so I think this is an alternative. We can also do with match, but it's a syntactic sugar kind of thing. Personally, I think sometimes I feel like too many options to do the same thing might create weird kind of patterns in the language. If you have a very restrictive syntax, like only one way of doing something, um, that's better. But yeah, I think it varies. It's very subjective and it varies from person to person. Cool. So if we do a cargo run and this function is not used, so we have to use it under main 6 if let. Let's see. I think that should be the case. Because it's not coin state quarter, but if I initialize with this value, got it. Awesome. So that's, I think, the wrap up summary here. Then we say basic Rust literacy, using modules to reuse and organize code. When you start writing program in Rust, your code might live solely in the main function. As your code grows, you will eventually move functionality into other functions for reuse, better organization. That is totally true. I mean, things can go horribly wrong if we have everything in a single file. I mean, not wrong as in like the program won't run, but it's also, if you want to modify the program, you want to have readability, there are certain things. If we maintain that, it'll be easier. Eventually move functionality into other functions for reuse and better organization by splitting your code into smaller chunks. Each chunk is easier to understand on its own. But what happens if you have too many functions? Rust has a module system that enables the reuse of code in an organized fashion. In the same way that you extract lines of code into a function, you can extract functions and other code like structs and enums into different modules. Module is namespace that contains definitions of functions or types, and you can choose whether those definitions are visible outside the module, which means they're public or not, they're private. Here's an overview of how modules work. The mod keyword declares a new module. Code within the module appears either immediately following the declaration within curly braces in another file. By default, functions, types, constants, modules are private. The pub keyword makes an item public and therefore visible outside its namespace. The use keyword brings modules or the definitions inside modules into scope, so it's easier to refer them. We will look at each of these parts to see how they fit into the whole. Mod and the file system. We will start our module example by making a new project with Cargo, but instead of creating a binary create, we will make a library create, a project that the other people can pull into their project as a dependency. The rand create in chapter 2 is a library create that we used as a dependency in the guessing game project. We'll create a skeleton of a library that provides some general networking functionality. We will concentrate on organization of the module, but we won't worry about what code goes in the function bodies. We'll call our library communicator. By default, Cargo will create a library unless it is a type of the project is specified. Okay. Cargo generated source slip instead of sure. So we go outside. Cargo new communicator. Huh. If we omit the minus minus binary option we have been using in all of our chapters, our project will be a library. Where is the lib.rs? It's not coming right. Is it something changed recently? Communicator. I think there should be a different way to create the library. Cargo help. So we have to explicitly say lib. Now I think if we look at it, it should be fine, and we can also just open that. Communicator source lib. Now it already has tests here. And it also added like an example. Let result add 2 and 2. Cargo creates an empty test to help us get our library started rather than the hello world binary that we get when we use the minus minus bin option. We will look at the hashtag and more test syntax and in the using super to access a parent module section later in this chapter, but for now leave this code at the bottom of this. Okay, because we don't have a source main rs file, there's nothing for cargo to execute with the cargo run command. Yep. Therefore, we will use the build command to compile. Makes sense? We'll look at the different options for organizing library code that will be available in a variety of situations. For our communicator networking library, we will first define a module named network that contains the definition of a function called connect. Let it be the mod network. After the mod keyword, we put the name of the module network and then a block of code in curly braces. Everything inside this block is inside the namespace network. That makes sense. In this case, we have a single function connect. If we wanted to call this function to a script outside the network module, we would need to specify the module and use the namespace syntax, like so, network connect rather than just connect. We can also have multiple modules side by side in this name source lib.rs file, for example, to also have a client module that has function named connect. So I'm trying to understand if we can have independent function along with modules. We can just check if we build it once. Car. Now I think we have to go to the communicator and then do a cargo build. What about we do a cargo clean? So we got some warnings, generated 2 warnings that functions are not used. Now we have these 2 functions, network : connect and client : connect. These can have completely different functionality and the function names do not conflict with each other because they are in different modules. That makes sense in this case because we're building a library. The file that serves as the entry point for building a library is lib.rs. However, in respect to creating modules, there's nothing special about lib.rs. We could also create modules in source main rs for a binary create in the same way as we are creating modules in source lib.rs for the library create. We can put modules inside of modules, which can be useful as your modules grow to keep related functionality organized together and separate functionality apart. The choice of how you organize your code depends on how you think about relationship between the parts of your code. Client code and connect function might make more sense for users of our library if they were inside the network namespace instead. That makes perfect sense. So we can have this kind of nested structure as well. Replace the existing mod network definitions with the ones in listing 7.2. Yeah, that I think we are done. So now the warnings, I believe, will be different. Function connect. So hierarchically we have this communicator, then network, then connect. It doesn't say which connect it is, it just says like two connects that are there. Okay, moving modules to other files, modules. Actually, in fact, if we see, like we were using the modules unknowingly, like we copy pasted some pattern from elsewhere, and that we have been already doing. Like we have these modules where we are sort of dereferencing under that namespace, like whatever we have in that chapter, which means, yeah, so we will have something similar to this. Like if we put this under a library, so I think that could be one quick exercise, is we make our entire tutorial set as a library, and then we call it from a test function, where basically just we test all of those stuff. Let me try to do that. So a better way to, let's actually do a cargo clean, but I don't want to see it every time. So a better way to do that would be, I have communicator here and tutorial here. I can create maybe another library, and this library can have a dependency on the other library. And inside that, we can run these different tests that we are running. I believe we can still run tests from outside. Let's actually go over a little bit more on this. I don't know how many pages are remaining still. We have already using modules, mod and the file system. Controlling visibility, we haven't come to this far yet. And then importing names. Then we go to common collections. Yeah, I think let's finish chapter 1 of the basic Rust library. Then probably we'll have some more understanding. So coming back to where we left, we have sort of tried to organize the structure in this manner. We can have modules and then modules within modules. The hierarchy shows how we keep it. Moving modules to other files, modules form a hierarchical structure, much like another structure in computing that you're used to, like file systems. We can use Rust's module system along with multiple files to split up Rust projects, so not everything lives in source lib.rs or main.rs. For this example, let's start with the code from this. So we have this mod client, function connect, then network, we have connect, and then server, we have connect. Client, network, network server. That makes sense. If these modules had many functions and those functions were becoming lengthy, it would be difficult to scroll through this file to find the code we wanted to work with. Because the functions are nested inside one or more mod blocks, the lines of code inside the functions will start getting lengthy as well. These would be good reasons to separate the client network server modules from the lib.rs. Replace the client module code with only declaration of the client module so that your this looks like the following. We are still declaring the client module here, but by replacing the block with a semicolon, we are telling Rust to look in other location for the code defined within the scope of the client module. In other words, we have this module client where content is client.rs. Now we need to create external file with the module name, create a client.rs file in our source directory, open it, then enter the following, which is the connect function in the client module that we removed in our previous step. We don't need a mod declaration in this file because we already declared a client module with mod in source lib.rs. This file is just provides contents of the client module. Okay, yeah, so I think we will get similar kind of warnings here. Actually, it shows the indentation also. I don't know if there is any benefit of that, but that's interesting. So if I create a new file here, network.rs, we still have a mod declaration within the module file. This is because we still want server to be a submodule of network. Connect mod server. Perhaps I'm a bit slow here. Make directory calls network here, and then move to source network, it's a new file name, and move source on lib.rs source slash network. So move source network lib.rs to source network server.rs. I think we skipped a step here. So in file name this, we should only have this. So let's file name network, right? Um, what is that? So did we rename network mode? So file name network will have just this much, and then the server will have only function connect. So this is not actually the structure that we are getting, right? So communicator, where is client? So we have, I think there is one piece that is missing. Yeah, this file should be there. Otherwise, how would it work? And this file will have the mod client, mod network, no module found mod. So now I think we can move it there. I think the client Rust function we are missing here somewhere. Let's actually, I think we messed up overall in terms of the structure. So let's redo this. I think in our next session, because I think it's already we are near the end of it. But I don't think like this structure organization happened quickly. I skipped over a few of the sections. So we'll redo the modern file system in our next session. So today I'll end this session in a very ad hoc manner, but apologies for that. We'll again meet up in the next session. Thanks again for watching. Bye bye.